Good day, students. Last time that we met, we looked at temperature, and today we still want to continue with the topic. So today we are going to be looking at how to determination of lower and upper fixed point of a thermometer. Now, our lesson objectives, at the end of the lesson, you should be able to explain temperature points and temperature intervals, temperature points and temperature intervals. They should be able to explain determination of lower fixed points and upper fixed points. Then also explain why water is not a good thermometric liquid. Now, temperature points and temperature intervals. Last time we were looking at temperature points and temperature intervals, but because of our time, we're not able to actually, talk more about it. Now, today I'm going to teach you the temperature point and temperature interval. What does it actually mean, temperature point? Now, when you say temperature point, last time I told you we have upper fixed point and the lower fixed point. Now, when you say lower fixed point, we can have a centigrade scale. Let me first give you the type of scale you can have. You can have centigrade scale. You can have Kelvin scale. You can also have Fahrenheit scale. So, and each one of them has its own fixed point, has its own temperature point. For centigrade scale, look at me. I have, at this point, this is 0 degrees Celsius. That's the lower fixed point. And for upper fixed point, you have 100 degrees Celsius. Then for Kelvin scale, you have 273 Kelvin as the lower fixed point. And we have 373 Kelvin as the upper fixed point. Then for Fahrenheit scale, we have 32 degree Fahrenheit as the lower fixed point and 212 degree Fahrenheit as the upper fixed point. Now, what do we mean by temperature interval? These are temperature points. This is the lower fixed point for a centigrade scale. The lower fixed point of a centigrade scale is 0 degrees Celsius, while the upper fixed point of a centigrade scale is 100 degrees Celsius. Now, the lower fixed point of a Kelvin scale, on a Kelvin scale, is 273 Kelvin, while the upper fixed point is 373 Kelvin. Then, of course, for Fahrenheit, also, the lower fixed point is 32 degrees Fahrenheit, while the upper fixed point is 212 degrees Fahrenheit. Now, what do we now mean by temperature intervals? Now, temperature interval, what does it actually mean? It means the difference between the lower fixed point and the upper fixed point. Now, that means we have centigrade scale has its own temperature interval. Then Kelvin scale also has its own temperature interval. Then degree Fahrenheit also has its own temperature interval. For centigrade scale now, the temperature interval is 100. That's 100 minus 0. That is 100. Then for Kelvin scale, we have 373 minus 273. That's also 100. But for degree Fahrenheit scale, we have 212 minus 32, which is going to give us 180. So you can see for centigrade and Kelvin scale, they have the same temperature interval. But for degree Fahrenheit scale, it's different from the two of them. So now, how do you determine the lower fixed point and the upper fixed point? Now, lower fixed point, like I defined lower fixed point last class for you, that is the temperature of a pure melting ice at standard atmospheric pressure. Now, if you want to determine that, you determine it by placing the thermometer upright in pure melting ice. Why are we using pure melting ice? Because pure melting ice is at 0 degrees Celsius. So, and then contained in a glass funnel. Then we also have the upper fixed point. It's also determined using what we call a hypsometer. This hypsometer is a double word vessel. So, and that is what you use to determine the upper fixed point. The upper fixed point, don't forget, is the temperature of the steam at the normal standard atmospheric pressure. Then we also, lastly, let us look at why water is not a good thermometric liquid. Now, when you talk about thermometric liquid, in glass thermometer, we have either mercury or alcohol as your thermometric liquid. And there are reasons why we chose mercury or alcohol. But why water is not a good thermometric liquid? One, it has a small range of expansion. What do you mean by that? Water freezes at 0 degrees Celsius. And why it also boils at 100 degrees Celsius. This is 0 degrees Celsius. then 100 degrees Celsius. Water boils at 100 degrees Celsius. So then it does not expand uniformly. It does not expand uniformly. That's the second reason why it is not used. It is not a good thermometric liquid. Then it's wet glass. And of course, the last point is that it is colorless. So this is thermometric liquid. So these are the main reasons why water is rejected as a good thermometric liquid. So in Google Classroom, we are going to be doing more of this. Thank you for listening.